If we want to deal with the most basic arithmetic of complex numbers, that is addition and subtraction, the best way to think about this is to sort of picture in your mind as you're working that instead of being a plus bi or c plus di, a single complex valued number, this is more like a plus bx and that's c plus dx. That it's like you're taking a monomial linear term, like what we saw in our last few sections, and when you add those up or subtract them, you think in terms of matching the pieces. So the constants, the real parts here, match up with the x coefficients, the imaginary parts. In this case, where one thing to bear in mind as well, it's common notation to put a plus in there between the parts of a complex number, but it doesn't need to be positive. That could be a minus bi just as well in practice, as we'll see with some examples. But anyway, point is, if you're going to take one complex number, a plus bi, add or subtract another c plus di, you'd end up with a plus or minus c plus b plus or minus d, I. You'd be grouping the terms together, you'd be matching them up. And thinking in terms of that complex plane that I mentioned, we're not going to spend a lot of time on it in this class because it is more of a pre-calculus topic, but if you want to think about what this addition looks like, it's something like forming a parallelogram where two of the sides are the original number, and then you end up at another vertex with copies at the end. But like I said, the geometry is a bit beyond us. We're not advanced enough to draw shapes just yet. We'll get there, though. Anyway, for now, we'll just take a look at some basic examples for how this stuff works in terms of the arithmetic itself. So for this example, we want to perform the indicated operations, leaving our answers in standard form, where we have 4 minus I plus 2 plus 3i, and 2 plus 2i minus 1 plus 7i. Where when you're looking at these, it's kind of tempting to see it, instead of being two numbers, as four separate things that kind of match in places. But remember, each of those parts is itself a singular complex number. The complex numbers always consist of two values, even though sometimes one of them is 0, so it doesn't do very much, it is still there. So for that first case, when we're looking at adding up 4 minus I and 2 plus 3i, again, what we have to do is match our terms. So we have 4 minus I plus 2 plus 3i, where matching terms means matching the 4 with the 2. So we would end up with 6 from 4 plus 2, and then you match the terms on I, so you'd have negative 1 plus 3. Remember, there's a negative 1 hidden on top of that I. You just don't generally write it in our number system. So what you'd end up with there is 2i. Similarly, for the second expression, excuse me, lost my head there for a second. For the second expression, I just said second too many times. We're still going to be matching these terms, but now we're working with subtraction. So when we're looking at 2 plus 2i, minus 1 plus 7i. Let me just make it a little bit clearer that that's a 1 there. It's not great in context. We're again going to match up 1 with I, so you subtract 1 from 2, you're left with a 1, and then over here you have 2 and 7, you're subtracting 7 from 2, that leaves us with negative 5i. So like I said, this is in form a plus bi, it just happens that b is negative 5. Don't get thrown off there and assume that these always have to be positive, because that's, well, how we often write them. But it's okay. Anyway, this is basically all there is to adding and subtracting complex numbers. So naturally, the next place we might ask ourselves to go is what happens when you multiply them. And that is where we're going to go. The next one.